that if you write it as a perfect square, you can write it as an exponent as well. So x minus 6, write it as this. And then from there, you know the axis of symmetry, the first part of the vertex, is always the opposite of this. So it's going to be positive 6. And if you need to remember why, just keep in mind that because you want to know when it equals 0, call this if x equals positive. That's why it's the opposite. But this is the key to vertex form. Is writing it with power of 2, which means both of these have to be the same, which means you have to kind of really work this whole system backwards. But to keep that in mind is that you're just doing the same thing you've done before. What adds a negative 2, with both numbers have to be the same, so that they have the same factors, so that's just really half of whatever this is. And then they multiply the positive 1, and that will let you know what the C value is, which is always positive because these have to be the same numbers. So whether they're both positive or both negative, they always multiply the positive number. So this will indeed factor to this, which is vertex 1. Okay. So here the vertex, of course, is positive 1. There's no number on the outside, and we can get to that on the back right now, but if there ever is no number, it's automatically a 0. And we always know the y-intercept is that C value that we ended up getting complete square. That was always positive. So we know that. We know an awful lot that we can use the graph. And relatively a little bit of room to find out. So we saw we went over equations a second ago and how much work and room it took to write all that out. This is relatively small, and we're getting the same information. Don't have the x-intercept yet, that'll be tomorrow. All right, so the next question is, looking over the back, how do you do this when it's not a perfect square? So what number do we need here? Actually, no, I did the front really well. What number do we need to be right here instead of 8? 4, right? So you can tell that maybe the x, and when we're doing on the front, after a while, you not really need to write out all this work. If you can look at this and say, well, half of negative 2 is negative 1 squared is positive 1. You don't really need to write all this out. You need to get it to you faster, at least when we're so, but you needed to. You can always look at this and say, well, it adds to 4. Two numbers that are the same that add to 4 are 2. So that's how everybody just said 4 really flat. Right? So we need this to be a 4. Now we can't just get rid of it and say, well, I don't like 8, I want a 4 instead. But we could write it as a 4, and just to make it equal, put another plus 4 right after. So what we have now, x squared plus 4x plus 4, and this part right here, what does that factor? X plus 2 squared. Right? So we got x plus 2 squared now. So these three right here factor to x plus 2 times x plus 2, which is x plus 2 squared. And now we have this plus 4 on the outside. So there you go, we just moved it over. So now our vertex isn't just something number 0. We got our vertex at negative 2. Is this opening up or down? What's the y-intercept? Look at the original question. What's the y-intercept? Yeah, just Just like on the quiz, you plug in 0. So you can see there's some benefits to vertex form, or to get the vertex right away, but the standard form still gives you the y-intercept really quickly as well, at that c value. Okay. So then you can get your graph like that. If you want to be more accurate, you can plug in -3 and -1 and find out what their values are. So look how much work, how much writing we have to do, and we have full vertex, and we have the y-intercept, a lot less if we know the path. Now notice how I'm not asking for x-intercepts, but on here, what are the x-intercepts? We factor this. We went through this and tried to factor in what would we get? Well, multiplies with 8 as before. And you can tell by looking at the graph, there are no x-intercepts. It doesn't cross here at all. So this should be impossible. If we're able to factor this, but our graph says, no, it crosses at this value, even if it's a decimal, something's up. So yeah, this is prime. You can't find two numbers that add to 4 and multiply to 8. That's why there are no x-intercepts. It's impossible. Now, prime can also mean some radical, like the root could be like square root of 2, which you won't be able to get, which would be prime as well. Or we're not a prime polynomial here. Will mean there's no x-intercept. So you'll notice a lot of things all coming together at once. Let's do one more. I'll leave you with the last 4 just on your own. So let's complete the square. What number do we need here? So if you need to, keep writing it out until you don't need to. So add to -2. These two numbers have to be the same. -1, -1, which multiply to positive 1. This needs to be a positive. And to keep it equal to above, -3, what should we do? So 1 plus or minus what equals -3? 1 minus 4 is -4. So these have to equal each other, right? Whenever this is -3, it has to be equal. We're replacing the -3 with 1 minus 4 because we need that 1 to complete the square. So I have to put a -4 there so it equals -3. Plus 2 equals positive 3, not negative. So the sign does count. So these right here, you know, factor to x minus 1, right? There's 2 of them. So it's x minus 4 squared. And then we have that -4. So vertex is at 1. Y-intercept is -3 from the standard form above. Now, what if we try to factor this one? Maybe this one factor. What multiplies? We take the original question. What multiplies to -2? No, adds a -2 multiplies to -3. Plus 1. So that means the x-intercepts would be 3 and -1. So here we go, 3, -1. So here, once factorable, we can still get the x-intercepts. Tomorrow I'm going to show you how to take this format right here and get the same 2 answers. So you don't have to factor again. So that's what tomorrow is. How can we take this and And without factoring, pick those two answers when there are two. So you just have just 4 of those to do on your own. Okay. Not easier, not harder. The order of these could be in any order. They're all about the same. Okay. Now, I will warn you right now, these are all nicely made up for you. Nicely by this. These are all equal to 1. So there's no like 2x squared, 3x squared, and they're all positive. So there's no negative 1s, negative 2s. And second of all, these are all even. Those are all even numbers. So it's very easy to take half of it to get your answer. And so on here, like, what's half of 4? Well, it's 2 and 2, that equals 4. But what if that answer was 5? What's half of 5? Yeah, 2.5 or 5 over 2. And now your C value is 25 over 4, and there's fractions involved. It's not any different, there's just fractions involved. So just know that it will get a little more complicated than this when we put in some odd values right here, and when these are something other than 1. So we're just starting at the very basics, but once you get this down, there's just a few little things you have to change. All right, so have that finished when you come into class tomorrow, and have a good day.